Okay, so this section is 8.4, other functions and their properties. One of the things that's nice about going to the book is, I don't know if you've actually hovered over these particular items right here, but these are other videos that you can watch that will help you to start to understand what this section is about, and how do you go about solving stuff. It's a nice helpful tool. So if you feel like, hey, I'm still need some more support, here's some other resources to help you. Okay, so when we're looking at nonlinear functions, it's something like a graph that we have right here. So this is a graph of the the basically deaths from AIDS in the United States, and this is the number of deaths, and then this is the years as it has passed. So you can see this is not a linear equation at all. It's got this curve to it. So you can see that this is why we need to start looking at equations or functions that are not linear, because there's a lot of real world situations that encompass this kind of thing. And so if we want to express the domain and range for these nonlinear functions, we have to take some into account. So let's look at these three examples here. So I'll go back to my little pad so we can do that. So the first one that we are going to do is a linear equation, f of x equal to 4x. Okay, and if you were to graph this on your calculator, you can see that it is a linear equation. So I'm just going to go ahead and turn it on and graph it. So that's 4x, and then I'll do zoom 6. And then I have my graph, so I can see that, yeah, it is a linear equation, and I can write my interval notation. So the domain of this particular function is going to keep going to the left on and on, because this curve is going on. And so I need all the x values in this direction in order to keep making this particular graph. Same thing going in this direction. I need all the x values to keep making this graph. So to do that, then I would write my interval notation for domain is going to be parentheses, negative infinity. Actually, let's back it up. I was going to do a bracket. I knew that that was wrong. So it's going to be bracket, negative infinity to positive infinity. Okay, and then the range would have been the same thing. So bracket, oh, totally wrong. Sorry about that. It is parentheses. So let's go back. It is parentheses because it's not a number, right? So parentheses, negative infinity, comma, infinity, parentheses. And then for range, it's the same thing, because we need all the y values in both directions to keep that curve going. So you can see that in this curve. So as I keep going along this curve, I need all the y's. And from here, I need this y. Here's one, I need this y. I need all these y's to keep making this curve in this direction and in the other direction. All right, so let's take a look at a different equation. Let's say we're doing the square root. So second square root of x minus 1. So x minus 1. And then we graph that. And then you can see that it starts right here at 1. Okay, so that equation is, again, we do f of x equal to the square root of x minus 1. And so we can see from the graph that for the domain, the x value starts at 1 and it keeps going to the right, because this line is continuing to go on forever. So my domain is going to be, it's going to start at 1, so it is a bracket this time. And then it goes to positive infinity, which is parentheses. And then for the range, it starts at 0 and goes to positive infinity, because you can see that in the graph as well. here it starts at 0 for the y, because there's a y right here. And as we keep going up in this direction, this curve is going to continue to go up, 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 up. And so that's y is positive infinity. Okay, the next graph we'll do, we go into our calculator, we'll do the 1 divided by the parentheses of x plus 3, right? And that's closed. Alright, and then if I graph that, it does this. So it looks like it's all the points except for the -1. It will not cross the negative, no, not the -1, but the -3 value in my graph. Okay, so for this one, we have f of x equal to 1 divided by the x plus 3. And so x cannot be -3 because this would make this to 0 in the denominator. So my domain in interval notation is going to be written as a union. So it's going to be parentheses negative infinity all the way up to -3, but not included. And then it's union with the -3 all the way to positive infinity. Okay? Terrible infinity there. Infinity. Okay? Or we could just say x, all the reals except for x not equal to 3, -3. And then for the range, okay, the range, take a look at the range again. The range is all of the y's. There isn't a y that I can't use. I can use any y that I want because it's, well, I can't use y equal to 0 now that I think about it, because this line keeps coming closer and closer, but it never crosses the y at 0. Okay, so we would do that for the y. So then there's parentheses negative infinity to 0, and then union 0 to positive infinity. Okay, and so that's what it would be. Or we could just say y does not equal 0, but all the other numbers. Okay, so this is 3 different examples on how to do that. Okay, so that you can write the domain and the range for different functions.